Imagine you're a developer or part of an IT team, aiming to focus on building and deploying your applications without worrying about infrastructure management, scaling, or complex configurations. Google Cloud Run is designed precisely for this, enabling you to run your applications in a fully managed, serverless environment with ease and efficiency. Now, let's dive into how Cloud Run works and what makes it so powerful. Cloud Run lets you deploy your application as a container image. This approach provides flexibility, allowing you to package everything needed for your app, from dependencies to configurations, within the container. It supports multiple languages, frameworks, and runtimes, whether it's a lightweight web service, a back-end API, or a complex business application. Once you've containerized your app, Cloud Run takes care of the rest, handling deployment, auto-scaling, and infrastructure management behind the scenes. Auto-scaling is one of Cloud Run's standout features. Say you're launching a new product that's expected to go viral. With Cloud Run, you don't need to worry about your infrastructure keeping up. When demand surges, Cloud Run automatically scales up your application instances to handle the traffic. Once the demand drops, it scales back down, even to zero, so you're not paying for unused resources. Speaking of costs, Cloud Run operates on a pay-per-use pricing model. You're billed only for the resources your application consumes while actively handling requests. No idle charges, no pre-provisioning, just a cost-effective, efficient way to deploy applications. Security and networking are integral to Cloud Run. It includes integrated IAM, identity and access management, which allows you to finally control access to your services. This means you can specify who can invoke your services, whether it's specific users, applications, or other services. Cloud Run also supports HTTP and HTTPS endpoints, enabling secure connections for public or private access. One of Cloud Run's biggest advantages is its compatibility with Kubernetes and Google's other services. If your team uses Google Kubernetes Engine, GKE, or plans to integrate with services like Cloud's SQL for managed databases, Cloud Run fits right in, simplifying connections and configuration across Google's ecosystem. For instance, with Cloud Run's fully managed environment, you can integrate with Cloud Pub/Sub for messaging, Cloud Storage for file storage, or Secret Manager for managing sensitive data like API keys or tokens. Cloud Run even supports custom domains and SSL certificates, allowing you to make your application publicly accessible with your own branding and secure encryption. Plus, it's compatible with continuous integration and continuous delivery (CI/CD) pipelines. This means you can set up automated pipelines that build, test, and deploy your application on Cloud Run, allowing you to get changes out faster while maintaining quality and stability. But what about portability? Cloud Run is based on the OpenNative platform, a Kubernetes-based solution that makes it possible to run your Cloud Run services on Kubernetes clusters, whether on Google Cloud or elsewhere. So, if your company needs flexibility to move applications or develop a multi-cloud strategy, Cloud Run's native foundation makes that feasible. Another unique feature is Cloud Run Jobs. These are ideal for background processes or batch workloads, like cleaning up databases or processing large datasets. Cloud Run Jobs allow you to define a container that runs to completion, rather than staying live to handle incoming requests. Finally, Cloud Run is simple and accessible to developers of all experience levels. From startups to enterprises, developers can focus on the business logic and innovation within their apps rather than managing servers or infrastructure. And with its consistent support for standard HTTP requests, Cloud Run is straightforward for any developer familiar with web applications or microservices to get started. In summary, Google Cloud Run provides a powerful, flexible, and secure way to deploy containerized applications without the heavy lifting of infrastructure management. It auto-scales with your needs, charges you only for what you use, integrates seamlessly with Google Cloud, and enables portability through native. Whether you're developing a new app, scaling an existing service, or integrating with a CI/CD pipeline, Cloud Run has you covered with serverless simplicity and robust cloud-native capabilities. And that's the essence of Google Cloud Run, a straightforward yet powerful way to bring your applications to life in the cloud. The developer workflow for Google Cloud Run is designed to be simple and efficient, enabling rapid development, testing, and deployment. Here's a streamlined look at how developers can work with Cloud Run, from writing code to deploying live services. 1. Code the application. The first step is to build your application. Cloud Run is versatile. It runs any code you can package into a container image. Whether you're working with Node.js, Python, Java, Go, or any other language, you can use your preferred tools and frameworks. Once your app code is ready, it's time to prepare it for deployment. 2. Containerize the application. Next, you package the application into a Docker container. Docker containers bundle everything your application needs, like dependencies, configurations, and libraries, ensuring the app will run the same way everywhere. Here's a quick overview of containerization steps. A. Create a Docker file. Define the image's setup, specifying the base image, dependencies, and how to launch your app. B. Build the Docker image. Use the docker build command to turn your code and Docker file into an image. C. Test the container locally. Run the container on your local machine to check for issues before deployment. 3. Push the container to a registry. Once the Docker image is ready and tested, it needs to be uploaded to a container registry. Google Cloud offers two options. A. Artifact registry, for more fine-grained control and multi-regional storage. B. Container registry, a straightforward option for Docker images. Use commands like docker push to upload the image to your chosen registry. T4. Deploy to Cloud Run. With the container image hosted in the registry, you're ready to deploy to Cloud Run. Here's how. A. Open the Google Cloud Console or use the gcloud CLI to deploy. B. Deploy using the gcloud run deploy command, which connects to the container registry, deploys the image to Cloud Run, and sets configurations like service name, region, memory limits, and concurrency. C. If you need auto-scaling and specific endpoints, you can configure these as part of the deployment. 5. Test and validate the service. After deployment, Cloud Run provides a URL for your service. Test the service to ensure everything works as expected. A. If you need private access, use IAM to limit access, or configure the service for public access if it's intended for general users. B. Test for performance, latency, and any specific metrics you might need to optimize, such as CPU or memory usage. 6. Continuous deployment and updates. Cloud Run integrates well with CI/CD tools for automated testing and deployment. A. Set up a pipeline using Cloud Build, GitHub Actions, or Jenkins to automate testing, building, and deploying new versions of your service. B. Each time you make a change, push it to the repository, and CI/CD will automatically trigger a new build, containerization, and deployment to Cloud Run. 7. Monitor and scale. Once deployed, Cloud Run manages scaling automatically. However, you'll still want to monitor the performance of your services. A. Use Google Cloud Monitoring to set up dashboards and alerts for metrics like CPU usage, memory, and response times. B. Set autoscaling limits if needed. Cloud Run allows you to control the maximum and minimum instances to avoid over-provisioning or cost overruns. Iterate and optimize. As you collect data and feedback from users, continue iterating. Make updates to your code, rebuild the container, push it to the registry, and redeploy. The entire process is designed to be quick and smooth, allowing you to focus on refining your application without worrying about infrastructure scaling, patching, or maintenance. And that's the core of the Cloud Run developer workflow. Code, containerize, push, deploy, and monitor. With Cloud Run's serverless nature, you can concentrate on delivering a high-quality application experience, while Google Cloud handles the infrastructure. This workflow enables fast development, scalability, and the flexibility to bring your ideas to production in a streamlined, serverless environment. Cloud Run supports both container-based and source-based workflows. Google Cloud Functions is a serverless compute service that allows you to run code in response to events without managing any infrastructure. It's ideal for lightweight, event-driven tasks like handling HTTP requests, processing data, or reacting to changes in cloud storage. Here's an overview of Cloud Functions, how it works, and when to use it. What are Google Cloud Functions? Cloud Functions let you run single-purpose functions in the cloud that are triggered by events from various Google Cloud services or external sources. You only write the code necessary to perform the specific task, and Google Cloud handles the deployment, scaling, and maintenance. Some key points. 1. Event-driven. Cloud Functions are triggered by events, like file uploads, HTTP requests, or messages in a pub/sub topic. 2. Fully managed and autoscaling. You don't need to worry about servers or scaling. Functions automatically scale up or down based on the number of incoming events. Pay per use. You're billed only for the time your function runs, with no idle charges. How Google Cloud Functions work. 1. Create a function. Write a function that performs a specific task. You can use several popular languages, including Node.js, Python, Go, Java, and C#. 2. Specify the trigger. Choose what event will trigger your function. You can set it to respond to an HTTP request, a pub/sub message, or a cloud storage event, among others. Deploy the function. Use the Google Cloud Console, gCloud CLI, or API to deploy your function. Google Cloud will take care of provisioning, scaling, and managing the infrastructure required for. Run the function. When an event occurs, Google Cloud automatically spins up your function, executes it, and scales back down after completion. Common triggers for cloud functions. 1. HTTP triggers allows the function to be called via HTTP, making it perfect for APIs or webhooks. 2. Cloud storage triggers a function when files are created, modified, or deleted in a cloud storage bucket. Great for image processing, file validation, or other storage-driven tasks. 3. Cloud pub/sub subscribes to pub/sub messages and runs the function when a message is received. Often used in data pipelines or message-driven architectures. 4. Firestore and Firebase triggers a function when data is added, modified, or deleted in Firestore or Firebase real-time database. Use cases for cloud functions. A. Microservices, lightweight services that respond to specific actions. B. Data processing, resize images, convert files, or transform data when files are uploaded to cloud storage. C. APIs and webhooks, quickly create an API endpoint or webhook that doesn't need a dedicated server. D. Automation, trigger tasks based on events across Google Cloud services. E. Data pipelines, process data as it moves between systems, especially in combination with pub/sub and BigQuery. Example workflow with cloud functions. Let's walk through a simple example. Resizing an image uploaded to cloud storage. On. Write the function. Write a function in Node.js that takes an uploaded image, resizes it, and saves it back to the cloud storage bucket. 2. Set up the trigger. Configure the function to trigger when a new image is uploaded to a specific cloud storage bucket. 3. Deploy the function. Use the gCloud function's deploy command or the console to deploy the function, setting the runtime, region, and memory allocation. 4. Run and monitor. Once deployed, every time an image is uploaded, the function resizes it and saves it as a new file. Use cloud monitoring to view logs, measure performance, and set alerts. Benefits of using Google Cloud functions. A. Simplicity. You focus on writing code for your function while Google Cloud handles infrastructure. B. Scalability. Functions scale automatically with demand, from 0 to thousands of instances as needed. C. Cost efficiency. The pay-per-use model makes it cost-effective for infrequent or low-usage tasks. D. Integration with Google services. Works seamlessly with services like Cloud pub/sub, Cloud Storage, and Firestore. Limitations of cloud functions. A. Stateless. Each function call is independent, so there's no persistent state across invocations. You may need to use a database if your function requires state. B. Execution time limits. Cloud functions have a maximum execution time, up to 9 minutes for the second generation. Long-running tasks may be better suited for other services like Cloud Run. C. Limited triggers. While it has a variety of triggers, there may be some cases where Cloud Run or Cloud Tasks is a better fit for specific architectures. Cloud Functions versus Cloud Run. While both Cloud Functions and Cloud Run are serverless, they cater to different needs. AC Cloud Functions is for event-driven tasks that respond to specific events, like file uploads or pub/sub messages. BC Cloud Run is for containerized applications that need more flexibility, such as running multiple endpoints, managing concurrency, or handling longer-running processes. Final thoughts. Google Cloud Functions make it simple to create single-purpose, event-driven functions without needing to manage infrastructure. Whether you're building APIs, automating workflows, or handling data processing, Cloud Functions provide an efficient, scalable, and cost-effective solution for running lightweight tasks in the cloud.